Hello, welcome to Notes 5.02, applying the slope formula. So remember, we have the equation slope. We denote with a little m. It's the m in the equation y equals mx plus b. So this refers to our slope. It's the change in the vertical distance, or delta y. So this triangle symbol here is called delta. It's a Greek symbol. So change in y over the horizontal change in x, delta x, okay? And the formula you've used in the past is y2 subtract y1 over x2 subtract x1. I am going to focus more on the rise and the run. So counting the boxes on your coordinate grid and looking at the rise and the run, okay? What are we going to prove using slope? Well, two things. We're going to prove parallel lines. And how can you prove this? Well, equal slopes means the lines are parallel. Well, you can also prove perpendicular lines. And that means the slopes are negative reciprocals. So I'm going to write slopes are negative reciprocal. All right. So those are two things we're going to prove using the slope formula. Okay, lines are parallel or lines are perpendicular. Now again, we're in coordinate proof writing. And the steps to the coordinate proof are as follows. Sketch the points. That's like our introduction. State your formulas. So that means slope or distance is what we've done so far. Show all substitutions. So this is like the body of your proof. And then we always end with a sentence. That's our concluding statement. And now in a couple pages here, we have a page in your packet, this one. It's coordinate proof concluding statements. So I've been doing a couple of these already, kind of intuitive, but we're going to practice some more of those. Right? So looking at exercise 1. It's given here that ordered pairs A, B, C, D, negative 1, 1, 4, 6, 8, negative 2, and 1, negative 3 are already graphed for us. And asks to prove that sides AD here and BC here are parallel. So we're going to find the slope, or m, of AD. And again, it's the rise and the run. So I always start at the point to the bottom and count up and over. So rise is 1, 2, 3, 4 boxes up and 2 boxes to the left. So that's 4 over negative 2. Now that would reduce to a negative 2 or negative 2 over 1. So we do tend to reduce our slopes. That just helps us compare two of them at the same time. And then BC. So we're going to have the slope of BC as well. So again, I have that little m of BC. And our rise and run here is going to be, and again, I'm starting at C, it's down compared to B, so I like to rise always first. 1, 2, 3, 4, 5, 6, 7, 8 up, and 1, 2, 3, 4 to the left. So 8 over negative 4 would also reduce to a negative 2 over 1. So those two slopes are equal. So our conclusion here is going to say this. Therefore, AD is parallel to BC because their slopes are equal. Okay, so that's our proof. We started with the introduction, was again our ordered pairs, which I'd already had graphed here for us. The body of the proof is to use your formulas and your substitutions. Notice I also kind of labeled it. I had the slope of AD we did first, the slope of BC we did second, and then we end with a conclusion. The next piece, prove that diagonals AC and BD are perpendicular. So those diagonals, we want to connect using a straight edge. This is the best thing I have here at my house right now. So B to D, and A to C, I'm going to connect using just the edge of this piece of paper here. So we want to prove that AC and BD are perpendicular. Now they seem to look like they are meeting at right angles. So we're going to find the slope of AC. So again, from C up and over to A, we're going to rise 1, 2, 3 boxes, and then we go to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that slope is 3 over negative 9. Then we have the slope of BD. And B to D, it looks like we have to rise and then run. So from D, I'm going to start again. I always start whatever points toward the bottom of my paper here. So we rise 1, 2, 3, 4, 5, 6, 7, 8, 9 up, and 1, 2, 3 over. So that slope is 9 over positive 3. So again, this negative 9 down here, wherever the negative is, it makes that whole fraction negative. This slope comes down our paper from A to C. So 3 over negative 9 reduces to 1 over negative 3. And 9 divided by 3 reduces to 3 over 1. Those two slopes, if I kind of circle them off here and here, okay, those are negative reciprocals. One slope is negative coming down the paper, one slope is positive. What that means is they meet here at right angles. So our conclusion here is going to say that AC is perpendicular to BD because B/C is my abbreviation for because slopes are negative reciprocal. All right, so again, we had the diagram. We had to connect our pieces as part of our introduction there. We did the body of our proof, was the slopes, and our conclusion. Graph quadrilateral lock with these ordered pairs, -2, -3, 0, 7, 5, 6, and 3, -4. So after we've graphed those four ordered pairs, it asks us to prove that lock is a rectangle. So we need this to be a rectangle. In order for a shape to be a rectangle, remember a rectangle is a parallelogram with right angles. So in order to prove something's a parallelogram, we're going to use the slope formula to prove two sets of sides are parallel. Now to prove something's a right angle, we're going to use slope to prove sides are perpendicular. So we really have two ideas here on how to use the slope formula. So what I do with my work is I go off and I find the slope of all four sides. So we're going to find the slope of LO, the slope of OC, the slope of CK, and then lastly the slope of LK. So those are our four sides. And the slopes are all fractions. Actually, leave myself a little bit more space between those last two. Now that I'm thinking I have to write in my fractions. There we go. Okay, so L to O, let's rise and run. So slope is the rise, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 boxes up, 2 boxes over. 10 over 2 reduces to 5 over 1. And that's positive slope. Rise to the up and run to the right. OC, again, goes up 1. Again, I start at whatever points farther down. Okay, so C is below O. So I go up 1 and then to the left, 1, 2, 3, 4, 5. 1 over -5. Now those two slopes I can see are negative reciprocals. CK is, again, we're going to start at the bottom point. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 over 2 is 10 over positive 2 reduces to 5 over 1 is a positive. And LK, we go down 1 and 1, 2, 3, 4, 5. -1 over 5. Now, again, it doesn't matter which point you start with, okay? As long as you're going in your vertical direction, up or down first, and then your horizontal direction, the X direction second. But remember, 1 over negative 5 and negative 1 over 5, those are equivalent fractions. So little reminder, negative 1/5 is equivalent to 1 over negative 5. It doesn't matter where our negative is. But some conclusions we can be making right now. First and foremost, these two sides, LO and OC, we showed had negative reciprocals, making those ones perpendicular, okay? But if I look at OC and LK here, again, if I'm kind of looping together OC and LK, those are equivalent fractions. So that means those slopes are the same. That means these lines are rising and running at the same rate are going to be parallel. So we're going to have 3 concluding statements we're going to have to end out our proof. We're going to have one statement about parallel lines, another statement about what's perpendicular, and then a final conclusion calling it a rectangle. So again, we have 3 conclusions here. Our first one is going to say that LO and OC are perpendicular because slopes are negative reciprocals. The next conclusion is going to tell me what lines are parallel. Well, this 5 over 1 and this 5 over 1 are equal, so I know that LO is parallel to CK. Similarly, OC and LK have those same slopes. OC is parallel to LK because slopes are equal. So again, equal slopes means lines are parallel. So we showed that way up here at the first question and here. Now we need to end our proof because really what they asked us to prove is that it's a rectangle. So remember, we always end a proof with our final concluding statement. So we're going to say that LOCK is a rectangle because it had 2 sets of parallel sides, which we just had restated here, okay, as part of our concluding paragraph, really. And what makes a rectangle is when you have a right angle. So here we said LO and OC were perpendicular, making that the right angle. So again, 2 sets of parallel sides is enough to call it a parallelogram, but then we have to go that one step further to call it a rectangle. So LOCK is a rectangle because it has 2 sets of parallel sides and angle O is a right angle. Right? And that's because of those negative reciprocal slopes we found here. So that's how we would prove something's a rectangle. We just counted out the slopes of the 4 sides and then wrote some concluding statements. Now what's really going to change here is these ordered pairs are going to become different. Okay, they might rotate that rectangle around the coordinate plane. It might change the 4 letters. But if you had to prove a rectangle, this is essentially the whole process you're going to take. Finding the slope of the 4 sides and then writing these 3 conclusions. Just the first parts might change those letters. This is really all that would change each time. Moving on to our next proof. And here's a little information for us. A parallelogram has opposite sides parallel, opposite sides congruent, diagonals that bisect. Trapezoid has only one set of parallel sides. An isosceles trapezoid has one set of parallel sides, and the non-parallel legs are equal or congruent diagonals. Now, each one of those statements technically has a formula that goes with it. Opposite sides parallel, we use slope to show that. Opposite sides congruent, we can use our distance formula to prove it. And we did that back on these other notes here when we used the distance to show 2 sides were equal for triangle DEF to be isosceles. When we had equal sides, we used the distance formula. So here, prove the quadrilateral ABCD is a parallelogram using the slope formula. Be sure to write concluding statements. So those four ordered pairs are graphed 1, 2, 2 up 5, 5 up 7, and then 4, 4 are our four sides. So that shape does definitely look to me like a parallelogram. AB and CD look parallel. BC and AD look parallel. So we're going to show that with our work here. So we're going to find the slope of AB. We're going to find the slope of BC. We're going to find the slope of AB, BC, CD is next. And lastly, the slope of AD. So I list off the four sides first so I don't forget any. And then I start counting. So slope of AB. From A up to B, we rise 1, 2, 3 over 1. Well, CD should be the same length, right? Because these sides are the ones running parallel. Let's go over to CD. Doesn't that go up 1, 2, 3 boxes and over 1? And again, it didn't print very nicely, but D is up 4, C is up 7, so we know that rised 3 and runs 1. BC, from B up and over to C, is up 2 over 3 boxes. Rise 2, run 3. A to D, rise 2 boxes, 1, 2, 3 over. So again, we found these lines are parallel. They have the same slope. These lines are parallel. So remember, this little M stands for the word slope. So that's important notation-wise. But this is the body of our proof. So again, these proofs start with an introduction, the ordered pairs graphed in the plane, which I did a good amount for us. Then we have the work. So here we're using your slope formula. Remember, is your rise over the run. Last but not least, we're going to write our conclusions. So our conclusions here, we're going to have two concluding statements. The first one is going to be based on this evidence. This evidence shows that these ones are equal slopes, the 3 over 1 and the 3 over 1. Same thing down here, 2/3 equals 2/3. So that tells me that AB as a segment is parallel to CD and BC is parallel to AD. So from there, we're going to finish that statement. These are parallel and these are parallel because their slopes are equal. Well, if I have opposite sides here being parallel and opposite sides there being parallel, then I know it's a parallelogram. So that's what our concluding paragraph, our last statement here is going to say. We had to prove it to be a parallelogram. So therefore, ABCD is a parallelogram because two sets of opposite sides are parallel. And how did we know they're parallel? Because their slopes are equal. So I know it seems redundant to kind of restate the same thing over and over, but that's how these proofs are formatted. Last but not least, exercise 4. I'd like you to pause the video, graph your trapezoid, it looks like. So prove TRAP is a trapezoid. A couple things as you graph. So again, we had 1, 6 is point T. 7, 9 is R. 13, 6 is A. And 3, 1 is P. So again, I graphed the 4 points first, then I put the letters in. Now I'm going to connect them. That just helps ensure that you've done everything correctly. And again, I do like us to use a straight edge as we're connecting. It's going to help your counting of your rise and run. The more precise you are here, the smoother the rest of the proof will go. Okay, so there's our 4 sides. Now that looks like a trapezoid. These sides look parallel. Now going back up to the top, it says at least one pair of opposite sides are parallel. So at least one means we only need to show the slopes of those sides. Now I'm going to get in the habit of always showing the 4 slopes. So we're going to find the slope of TR. Then the next side is RA. Then the slope of the next side is AP. And the last side is TP. So we're going to find the 4 slopes, rise and run. So T is up 1, 2, 3 to R. 1, 2, 3, 4, 5, 6 over. So the slope there is 3 over 6. R to A. Looks like it goes down first. 3 down. 1, 2, 3, 4, 5, 6 over. So down 3 to the right 6. Now those look like the same numbers, but they are not negative reciprocals. You really have to be careful. One is not flipped than the other. So that's definitely not a right angle. AP. And again, up or down first. So I've been starting at some of the top points and just showing you can go down and then to the left. But when you go down and to the left, be careful. 1, 2, 3, 4, 5 down. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 over. So that's -5 over -10 does reduce to +1/2. So we're looking for TR and AP to be parallel. True? These two sides are running parallel. So those two slopes should be the ones that are equal. So these are equal slopes here, 3 over 6 and negative over a negative. Again, I went down and left. Gives me a +1/2. And last one, PT is 1, 2, 3, 4, 5 up, 2 to the left is 5 over -2. Now these slopes are not negative reciprocals. These are equal. So our concluding statement, well, our first one is going to say that TR is parallel to AP because slopes are equal. And I did have to reduce the fractions there, the 3/6 and the 5/10, so that we did get those equivalent fractions. Okay, so those two sides are parallel because their slopes are equal. And then we can make a final conclusion. TRAP is a trapezoid because it has at least one set of parallel sides. And which sides do you ask? The ones we just stated here. So again, that's why we needed both statements. So those are the 4 proofs we're doing today. Again, we were just counting a bunch of slopes, rises, and runs. I'd like you to try classwork 502. So with this classwork, find the perimeter of ABCD. That's the distance around. Find the area. Again, that's a rectangle. So remember, area equals base times height. This is your sum of sides. No trick questions there. Okay. What is draw in diagonal BD? So you're going to connect B across to D. What is the area of triangle ABD or CBD? So that diagonal is going to break it up into 2 triangles. So try what you can there. That's kind of based off of notes 5.01. Here, AB and CD are just 2 separate segments. So -1, 4 is point A. 2, 6 is point B. So that's just one segment. A different segment, CD, is 1, 0 is over 1 up 0. And 4 up 2 is there. Okay. So those, it does not connect to make a shape at all. They're just 2 separate segments. So just decide, find the slope of each of them, decide if they're parallel or perpendicular with a little conclusion. Triangle bug, we want to prove it's a right triangle. Right triangles have perpendicular sides, which you can prove using slope to show perpendicular. Okay, so find the slope of the 3 sides of the triangle and try your own conclusions. So you should have 2 conclusions here. One conclusion telling me what sides are perpendicular, and then another conclusion calling triangle bug is a right triangle because, and then you can kind of finish that statement. Right? So we want you to kind of practice it all out there. On the next page, you have parallelogram math. You're going to prove it's a parallelogram using slope. And I'm going to say to see exercise 3 from the notes. Numbers 5 and 6. Here they want you to find the slope of the diagonals AC and BD. So you're going to find the slope of AC, find the slope of BD for the rhombus, and see what happens there. Write a conclusion. And this last one, number 6, they want you to find the length, which is the distance of BC, EF, and AD. And here, they're all horizontal. You can count them. And we want you to substitute those into the midsegment formula. So remember, EF is a midsegment. And this is back from our trapezoid notes. If you want to look back to unit 4.04, I believe was about the trapezoid. This might be base 1, and this would be base 2 if you're subbing in the formula. So again, we're using coordinate geometry graphed in the plane to kind of prove some of the rules that we've already learned in our last unit. Good luck. Email me with any questions.